All right, we are here with Ivan Domolazov. Thank you for coming on, man. You're going to share with us today a few things, so we have quite a lot to cover, but the general idea here is how you've managed to incorporate AI into your own workflows across Excel, Python, VBA, and others.
Thank you for having me today. I'm a bit excited about this session because the topic is very relevant for my experience and very practical for me. So I will cover today with a few cases, with a couple of them, how I used optimization and AI as a helper or as a copilot for real reservoir engineering works. Okay, the first case is a VFP viewer and nodal analysis tool I made in Streamlit. The goal of the tool was simple. Take raw VFP files, VFP text files that are output of well model, and turn them into fast visual screening of well performance at some working conditions. In Reservoir Simulation, VFP tables are often hidden somewhere inside text, inside the part of integrated model. They are kind of simple text file, but not very convenient for quick visual checks because it's I can just switch to my text file. This one is example of typical VFP model, and from human perspective, it's difficult to interpret, difficult to analyze, and makes any conclusions about relevance, correctness, maybe some issues inside the well model.
So the use case here, Ivan, is for somebody who receives a simulation deck and wants to inspect these curves.
Exactly.
They were not the ones who generated these curves. Probably they don't have access to software. So
exactly.
Yes, these are tricky files, and the use case here is for those people who want to inspect those curves.
Absolutely, because these files usually we got from our engineering team located in another country. It's like our vendors, and we have only an output as a part of integrated model. These files were delivered without well models itself, actually. So we didn't have access to pipesync files, for example. Okay, so as I mentioned, VFP files are raw text. Sometimes you have them separately without well model. Standard tools like VFP table generator, VFP analysis in Tempest, maybe Picture are limited or license dependent, and you need to check and make a decision. For example, whether these files are correct or have some issues, maybe in terms of history matching to real well performance, maybe in terms of roughness applied, maybe in terms of datum jobs well modeling engineer used to produce this VFP tile. So a lot of stuff, a lot of very small details, but still very relevant and very important for integrated simulation. And most common case from my experience, a lot of times I need it. Let's say I have a few nodes in VFP table, but I need to check well's performance in custom defined parameters. Let's say I have liquid flow rates 250, 200,000, 4,000. Okay, but I need to check well performance at flow rate, let's say 500 cubic meters per day. But I don't have this node in well model, and the only thing I can do is just to manually somehow interpolate the values to get the result. So the purpose of the tool I created was not only to check the correctness, but also calculate well's performance in any user-defined operating conditions.
Which is still an interpolation, but you provide the tool to do that.
Of course, it's a multi-dimensional interpolation for the case. Let's say producer, it's 1, 2, 3, 4, maybe even 5. But if it's natural flow, it's only 4-dimensional multi-nodal interpolation. Exactly.
Yeah.
Of
just to
course, of
clarify,
course,
you're not bringing the complexity of flow correlations. You're not redoing this. You're just interpolating
no, no.
from the course
The,
tables you received, and you created a tool to streamline that. Yeah,
exactly, exactly. So of course, it's not a replacement of official tool or something,
of
some kind
course.
of
Yeah.
replacing of PipeSim and Prosper. It's just a tool to quality check and
Yeah.
uh, quickly analyze and provide you expert opinion about the output of well modeling engineer. So I think it's time to switch. Just to cover what I switch, I already showed raw WP file, and I will show two versions of my Python tool. First version, okay, let's jump to VS Code. Just a minute. I already have a few terminal. Okay, VFP streaming application allows you to use a few well VFP files at the moment. Up to 6 VFP files can be loaded. It can be either VFP files for different wells. It can be VFP file for one single well, maybe for sensitivity check. I will use VFP model VFP file for one well, loaded 3 times just to provide some sensitivity for tubing head pressure as example to showcase. Okay, so let's load the file and let's set different tubing head pressures.
So sorry, man. Just to clarify there, what if you had a
Mhm.
deck with the one include file with all the curves in the one file for all the wells?
I will just use some tool to split them by, let's say, VP Prot or VP Eng
Okay, so
keyword.
this tool, the one you're showing on the screen right now, requires one input file per
Individual,
well.
individual, exactly.
Okay.
Yes, this is the way we used to deal with VP files in LUKOIL, but some for some cases, for some models, I know that people prefer to combine them into one file, but this is not an issue. I believe it can be split to hundreds of files just by VP keyword, VP Prot or VP Eng.
Yeah. 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 No, for sure.
Mhm. So let's set up sensitivity for tubing head pressure, 10 bars, 25 and 50. The tool provides option to switch units. So just in local, we prefer use cubic system. Okay.
So you convert here on the spots between units, regardless of the input units it comes in, or it's just for you to select the units in which it comes in, but you don't do the conversion.
It converts everything, the fields, input fields, and the charts it produces. When you switch, just let me showcase, and you switch to PCIs,
Yeah.
it immediately rebuilds with another unit of measurements.
Okay. So this is your selection of units, but the unit in which it comes in, it comes with the file.
Yes,
You don't need to
the units.
specify the unit in which it comes.
Yes, the tool assumes that in the file units are in metric system.
Yeah.
In metric, it's most popular system for simulation, even in Middle East, even in let's say in Schlumberger. Yes, I know. At least in Middle East, in Schlumberger, that works in Iraq and Saudi Arabia, something like this. Okay, here we are. We have the tool that creates wells performance in custom-defined operating conditions, and we can also set up IPR model. Okay, let's switch back to, and we can set up weather pressure, let's say 250 bars. That's second one, let's say 100. Okay, so here is combined plot, and it's showing, I don't know why it's only 2, it should be 3, of course, here. Yes, so we have a sensitivity case for one well, but with different tubing head pressures and a couple of IPR curves for different reservoir pressure.
Okay, just to clarify
And,
here, Ivan, the
mhm,
VFP curves is just
mhm.
reading the input files you specified in the top fields but the IPRs,
Yeah.
you're actually reconstructing them using an
Yes,
inflow
yes,
model.
yes, and this is the point where I decided to optimize the tool using AI. Just here we have just one single linear model, no any another option. So just linear trend, regardless of reservoir pressure, relation to saturation pressure, bubble point pressure,
So the input there for each IPR is the pressure, the reservoir pressure, and the PI. That's it.
and PI.
Okay.
That's it. Yes, correct. So jumping back to the slides,
Yeah.
I used the AI to assist me add combined IPR Vogel model as an option to build IPR curves
Okay.
on the plot.
Yeah.
So let's jump to AI chat. Okay, yes, here it's a starting point for this AI moment for VP tool. I used to optimize it and to add Vogel model for IPR curve building. So I used the simple prompt. I shared with the chat the whole Python script I developed before, and asked it just general question how I can modify IPR model, for example, for conditions below bubble point pressure. I know that Vogel model is most popular after linear PI curve type, but I wanted just to hear, like, to see from AI assistant which can be suggested maybe in addition to Vogel. But still, it's very expected that Vogel IPR was recommended, and it showed me some description of this, how it works. Here we had some kind of conversation. One critical point I would like to keep that if we switch to any deviated curve like Vogel model with some inclination, there shouldn't be any sudden drop at bubble point pressure. This is first condition. Second condition is that when pressure is higher, but bottom hole pressure is higher than bubble point pressure, the curve should still be linear without any inclination.
Yeah.
Because in our approach in local company, for traditional assets, for traditional reserves like in Iraq, we use only linear model to describe flow performance for bottom hole pressure range above bubble point pressure.
Yeah.
So I also described this moment that IPR still should be linear when bottom hole pressure is above bubble point pressure.
Yeah.
And it shall use a Vogel model when bottom hole pressure is below. Then our conversation continued. It showed me some formulas. Very long conversation. I found some inaccuracy in the formula the chat provided me. I also shared with it some academic page with formulas.
Yeah.
In this case, I rely to DAKE, Reservoir Engineering Handbook. Okay, so our conversation is still continued, and finally, it clarified me all differences, all abbreviations, all symbols, everything. It resulted in updated application that creates everything I need for Vogel IPR calculations. Okay, I think we can jump to stream it again.
Yeah. So in this case, the updated app that you got there is essentially the edited Python script with the
exactly.
Vogel implementation incorporated into it. Um, Now, I
Yes.
just want to mention that you are demonstrating the case in which you entered into a conversation with the chats
Hmm.
with ChatGPT and asked for recommendations. But alternatively, if you know exactly what you want to do, which is to have a Vogel implementation below the bubble point, you can just go directly with the Vogel equation and just ask
Yes.
Codex or ChatGPT to just give you the code. So of course you're demonstrating the entire capability, but especially if you already know what you want implemented, you can just go straight into that.
Sure. My idea was why I asked. It's very generic without specification of Vogel model. I wanted to know the output of if I ask generic question, assuming I don't know another types of model of
Yeah,
IPR model.
for sure.
It was like it was like a test of ChatGPT. Does it know does it know what is very relevant and very often used
Yeah, it's
for
interesting
IPR?
that incidentally in the
Yes.
demonstration you just made, it happened
Mhm.
to give you an error in the formula. So it also shows the danger if you don't know what you're doing and you are just
Mhm.
relying on the output, then you end up with a wrong implementation. So it's good that you did show
Uh,
in this demonstration what the conversation led you to. So it flags both the utility of it, but also the dangers if you don't know what you're doing.
yes, I'd like to show exactly this moment that if you don't know the formulas and you don't know um, what can be suggested, we will like a blind.
Yeah,
You will have to rely entirely on the output. But if you know the formulas and you know the source, academic textbooks, let's say reservoir engineering handbook, you will prove or correct the chat
exactly.
to.
So a
Uh,
recommended approach
mhm,
would be to extract the formula you want implemented from a reputable source, paste it as you
of
just did
course,
because it takes imaging here, and then obviously QC that
yes,
the formula, even if you don't understand the code, you can kind of figure
yes,
out
yes.
where the formula sits and you can QC quickly, just eyeballing whether the formula
Uh,
is right or not. But the point is you get the code with the new implementation in it. So that's the beauty of this thing. So you got there now
mhm.
the new
So
app.
here we have another. This is a new updated app, and already have option to choose from
Yep.
linear PI or Vogel combined. Let's create two versions.
And that
Uh,
optionality, those selectors, you did not ask for it. So you just had a natural language conversation and the
mhm.
output came with that interface with those selectors for the user to pick.
Yes, so
Good.
output the code already updated and provided as ready to use the tool ready to use.
Yeah, no, no, yeah. What I'm pointing at is you did not have to spend too much time specifying every little detail of the user interface you wanted. You didn't ask in your prompt, I want a selector where the user picks. So it just came out like this. So it's great because it has
Yeah,
already a lot of,
yes, it came out. Yes, it came
yeah,
out like this. I didn't specify interface features. I didn't specify how it should be named,
yeah,
how it should be organized. It just came as it is. Of course, if I
exactly.
need, I can tune it further,
Of course.
optimize, maybe make it more user friendly for some people, maybe who doesn't understand
Of
the
course.
structure, which is IPR 1, 2, 3. But it was done only for a limited number of people, for me and for my
Yeah,
back-to-back and for our managers. We are all engineers and understand this
absolutely.
correctly. So here already we have option to choose from linear PI only or combined Vogel. And you can see the difference. So for Vogel model, we have inclination below the bubble point. So also we can add some additional features. We can also customize access ranges. We can tune everything if it's needed.
And the bubble point there is an explicit input by the user. So can you just switch very quickly there just for the sake of demonstrating this? Put it in 250 or something for it to curve
Here,
super. Yeah,
here, okay.
yeah, and let's just see the chart.
Yes, it's
Yeah,
starts incline
yeah,
almost at the
it
beginning,
happens
from the
to,
beginning. It's
yeah, it
a
happens to
slight
be,
difference, of course.
yeah. If you put
Yes.
a high reservoir pressure, let's say 400 reservoir pressure initial, yes, just to have a little bit of a higher curve there.
Let's check.
Yeah, so
Uh,
it's good to
I
see. And now
believe.
you can put the bubble at 300, so you have
Let's check.
more room to observe.
Difference is very slight, I think.
No, that's fine. But I mean, this already shows the capability of the tools.
Yes,
I
it's fine.
think
It
it's
starts.
great.
It
This has
starts. It
great
starts.
utility, man. I mean, people may not appreciate if they're employees of large organizations and models are built inside and don't usually run into initially this, but it's not uncommon that you inherit a deck from someone else and you want to inspect these curves. So this is a very
Uh,
valuable utility to have.
yes, for our projects, it wasn't relevant because all our operating conditions stick to be above bottom hole pressure, above bubble point pressure. But for physical understanding and probably analysis of some uh, potential operating conditions, I decided to add some woggle model
Yeah, no, that
for
I
the
think this is an
tool.
add-on. This is an add-on.
Yes.
It's value on top of what is already very, very useful to have, which is the ability to inspect VHP curves from inherited ugly decks, which you can't do anything with. So yeah, this has immediate utility for those who do not have access to software and who inherit those decks. And on
Yes,
top of
yes.
that, you have the
Most typical issue was actually very simple stuff. It was wrong datum depth and wrong roughness for history matching. It was very common, and the tool allowed to check it very quickly, to find it very quickly, and send feedback for our vendors to update well models and update integrated model.
yeah.
So it was most common cases wrong datum types. It's very simple stuff, but still sometimes it can be overlooked and interpreted for further.
For the
Uh,
Streamlit,
i-
just curious, Ivan, for the Streamlit app itself, the Python
mhm.
code to interpret those input VFP tables, did you also lean on AI assistance
Do
to
you
get
mean
that?
to understand the
Yeah,
VHP structure,
yeah,
VHP tables?
yeah,
Actually, I also used AI, but I
yeah,
feed it up with a structure and described the keyword structure in the file. I described very precisely the slash logic, the slash after uh, some sections of
yeah,
VFP files, and where exactly it should find ranges of the nodes, ranges of the operating
sure.
conditions, rates, tubing head pressures, water cut, etc., and the nodes, of course. I
Yeah,
described it in very detail to AI to create multi-linear interpolation logic.
yeah.
And then I still have to say that even after very detailed description, after very detailed prompt, I used to manually check semi-nodal interpolation, uh, internodal interpolation for different examples.
So you did a manual QCing of the curves, made sure that
Watercut, let's say
very,
zero and yes, yes, yes. So you need to validate all intermediate steps, intermediate calculations to be sure that the output is relevant and
yeah,
physically reliable.
yeah, I think a couple of comments there. So one is this is very interesting for anyone to hear that you did not lean on your own coding skills to do that. Anyone could do. It's all about putting a precise, detailed prompt for the code assistant to actually
Yes,
be
exactly,
able to interpret
exactly.
this odd file and turn it into something readable, and you can turn that into plots. So that's really good for anyone to understand. And secondly, um, as you mentioned, you did have to do quite a bit of manual QCing. So one of the things that I usually do is I just cross-check across different modeling, different LLMs. So if I get an output from one LLM, I just send the same prompt and the output to another LLM and another one and a fourth one, just to just to gain more confidence that the code is
This,
actually right and is reading correctly.
yes, that is why I have another web tab streamed in Cloudy AI,
Yeah,
and I will briefly cover how I validated output of AI with another LLM model
yeah,
to compare the output for VFP2.
yeah,
For
exactly.
VFP2, that I will briefly cover this at the end of today's session. Okay. Okay, so let's switch back to the slides. Okay, sorry.
By the way, you are making this available to everyone, right? So your GitHub
Not all,
repo, not everything.
not all the tools, not everything. Yes,
Yeah, yeah, sure.
some stuff
Of
should be
course.
discussed. Okay, so we already passed through the approach how I use AI optimize to enrich the tool. Now I believe we can head to second case, the tool that generates simulation schedule from scratch.
Yeah,
The goal is very simple. Given reservoir development conditions, reservoir development strategy, scenario of well commissioning dates, conversion to ejection, perforation strategy, grouping, group constraints. So everything we need to describe simulation development strategy, how to turn this into a very strict and very unhuman language of simulator like Eclipse or maybe Tempest. So beginning point is very simple. We have a lot of inputs, very different keyword types, a lot of logic inside each keyword, a lot of arguments. I believe that any reservoir engineer and installation engineer knows very well and to be scared of this task. And this tool, I started at 2023, I believe in the first half of 2023, and I was crazy enough to start it doing in VBA, and I did it completely manually. I mean, VBA coding I did on my own without any assistance of AI. Just let me switch to Excel. The models. So we have actually a lot of models, a lot of VBA code inside the file. I can also show the whole PDF file with the code. So this is just a copy, just passed into Word and saved as PDF code. As you can see, 45 pages of coding here. 45 pages. Yeah, I was crazy enough to to create this in VBA to convert all the inputs.
how did you do the comdats, mate? I mean, I've done VBA for
Control
schedule, but everything but the comdats. When you have complex wells, deviated wells, and complex grids.
Comdat as well was once stored from Petrel as a database here,
Ah, okay.
and since we have a very rare whole model structure update, it's very it's very easier to keep it because
Yeah.
we
So
don't have changes
of
in IGK. IGK for all simulation cases same.
yeah, but
If we change
this obviously requires you have had this already exported from your pre-processing
from Petrel,
tool. Yeah, sure.
exactly. Yes,
Yeah,
you need to define simulation case, with the
yeah.
simulation case, and copy paste the completion competence section, of course. But still, you can create it a few times. Let's say for different permeability assumptions, maybe for different I don't know, for different P10, P50, P90 cases. mark them as, let's say, number option. Now we have only one option, but you can select as much as you need. And for description of wells, you just select the type of connection you need to choose from. It also can be used. You can generate a few completion databases for different models, as I mentioned, for, let's say, P10, P50, P90. And then in database of wells, starting dates, injection starting date, liquid rate control, you can select also completion option to choose from. So let's just show how it works. And I will show the issue we had for some users, especially for our users in another country. For some users who are Russian speaking and used to utilize Russian system of Windows, Russian Microsoft Excel, Microsoft Office, I will show an issue that sometimes was in place. It should take at least maybe 20, 30 seconds. Of course, it was done not in one day. It was done approximately during 2 weeks. I combined all the structure, the logic. Okay. So now it's time to see what was wrong. So as we know, dates requires very strict syntax after it. Dates, it's like moments of simulation.
Yeah.
And for some users, an issue was that instead of, let's say, September, Sep, they had Cyrillic symbols, like in Russian language. Here it's Russian language, September, for September. And an issue was the nature, the origin of this issue is very simple, because they had Russian Windows. And I was thinking of how I can fix it. So regardless of the Windows system they use, it should produce correct language, correct in English, of course. So how I managed to do it? Of course, I could deep into this problem and try to understand how it can be formatted, or maybe pre-formatted to use correct syntax. But I fixed it very simple. Okay, I just described the problem about this code, about that some dates in Russian style in the output file, and how I could fix it. Just very general, very natural human language is into conversation with AI, and it suggested me a few ways. I of course read this carefully, and I choose second option, define some function that will keep strict namings for all months. It will create just simple array and create some simple function.
Yeah.
I can use for all my dating procedures. Okay, let's jump to updated. Here we are. It's this password.
So
okay.
the overall workflow you're demonstrating now is you're just leveraging ChatGPT as an assistant to improve your VBA code.
Yes.
That's kind of the use case here.
Exactly. So it suggested me to use a function that will keep an array with all months definitions. That's Jan, Feb, etc. And use this function throughout all my VBA code to implement correct month namings in dates keywords. The only difference I applied here is just I had to make this function public. Public in VBA makes it global and applicable for all
modules,
for all models, for all sub functions, of course. So it was fixed very easily, very quickly, and I will not spend time now to demonstrate it again. So now we have all the dates and correct approach with correct Latin symbols. so ready to use for real simulation. This one is the first sub case. Second one I will show. So entire logic is kind of complex. I'll just show the slide to demonstrate that the logic here is not straightforward. The execution depends on, for each well, let's say production well or injection, which completion strategy is used first or second, maybe some another reperforation strategy in place. And initially, when I prepared this tool, I used it in very quick manner because the deadline was tough, and I hadn't time to optimize it after I created it. And second sub case of here, how the VBA code overall can be improved. Not only adding only one function to fix dates issue, but overall implementation of AI for overall coding change and optimize its execution. So bug fixing we already covered, changing month names for dating keywords. And second moment I would like to show now is how AI helped me to tune all the logic entirely, improve all code structure, and as a result, to make the execution of the code almost 3 times faster. So let's jump again to AI chat. For each case, I prefer to use different chats because not to mix them, not to mix conversation. So I feed up with original VBA doc, same kind I have here. So multi-page VBA code. I shared it with ChatGPT and asked it how it can be optimized. So just also very general starting of conversation. And my goal is to tune the code if possible in order to optimize the execution time. Very simple stuff, very natural language, I believe. Can you see?
Yeah, yeah, clear.
And once I shared a whole file, a whole document with VBA code, it resulted with a lot of suggestions how it can be improved. So it showed me a few ways, a few steps I can go through to optimize. Some explanations weren't clear. For first time, I just asked some clarification questions for keywords, for some syntax update. But it's not very important, I believe. The important stuff is that once I fixed and implemented all suggestions, execution time reduced more than 3 times. And this was very beneficial because spending each time 5 minutes to create schedule, it wasn't very convenient, of course. So this is a second subcase for schedule generation tool. Okay, now I would like to briefly discuss on where AI replaces humans' ability, and where I still need to keep an eye strong and provide engineering input, provide my human personal action to prove the result that I receive from the chat, from the cloud. So of course, AI helps with code structure. It helps with optimizing, with debugging. Maybe in some creativity, it can suggest some workflow ideas, maybe user interface features. It can generate whole code from scratch. Sometimes you can provide some input and get a whole result. in VBA or Python. And it can help you as a teacher. It can explain the syntax you don't understand. It can replace some maybe online courses on programming, on coding. But still, as an engineer, we had to be responsible for very important aspects. First of all, problem definition. No chat, no any AI tool knows your workflows. No any chat knows the structure you need to provide as your task requires. Engineering assumptions. Sometimes some models can be used to, let's say, the detailness of some models. Sorry, let's start from scratch.
Okay.
You still need to be responsible for problem definition. Engineering assumptions. By engineering assumptions, I mean the selection of the model, the selection of the formula. Maybe you need to apply formation volume factor equals to 1, maybe for water. For oil, you cannot use bottom volumetric factor equals to 1. Data quality. For example, when you deal with bottom hole measurement, bottom hole pressure measurement by gauges, you need to convert pressures to barres, to absolute pressures, before you use them in simulation model. Because bottom hole pressures usually provide relative pressure, but G's. Intermediate calculations, also very important aspect. You need to check manually all internal logical, internal calculation of the tool. And of course, final result, you need to check it across different tools, maybe across manual calculation. And one bonus feature I would like to just briefly discuss is how can you validate AI output with another AI. So I did small experiment recently. I did it. I already have ready to use VFP viewer. It's taken from case 1 today. VFP viewer with a Vogel model with all the features that are working well already. And I asked ChatGPT, how can I create the prompt to use for creating the same code structure, the same tool, but using, for example, with another AI tool, let's say Cloudy, for example. So I already have the tool, but I want to support, for example, my peers, my colleagues, to help them with prompting same ChatGPT or maybe another tool to get the same Python script, the same Python tool ready for their independent usage.
Yeah.
And the ChatGPT showed me very, very long and very detailed prompt that another user can use to feed another AI tool to create same style Python instrument. Okay, I even
back
didn't read
engineer
it
the
very.
prompt from the code.
Yes,
and then you're going to
yes,
paste
yes.
that into code and see if you
For,
get the same.
actually, if you did a careful quality check of the tool that already exists, I believe that it's enough. But for me, it was just tricky exercise and like small experiment how I can generate back prompting having already existing tool. For me, it was just kind of interesting exercise.
Yeah.
And having this output, I send it to Cloudy.
Yeah.
It's like this one. Same, exactly, just copy paste.
Yeah.
And it resulted with the created file. Or for now, it's from Cloudy AI.
Yeah.
And let me open it. So already in It's already in run. Just let me rerun it again.
So we're gonna put
Okay.
side by side the original and the newly generated code from the back engineer prompt in Claude.
Yes. So this one is from OpenAI, from ChatGPT. This one is from Claude.
So the UI is nearly identical.
Slightly different UI. Yes, user interface slightly different, but still very similar result, as we can see. Same option. You can choose four-wheel model, linear model. So it's very close, I believe. And it's interesting. It's very interesting
that's an
exercise.
interesting one. You get confidence on the code, man.
Yeah, same figures as you see, same numbers. So
absolutely,
it's kind of relevant.
Fantastic. What I like about this example, the other two examples on the VBA obviously starts from the fact that you had already created a massive piece of VBA code in a prior stage of your career,
Yes.
and you
Yes.
use now AI to bring efficiencies and improve the code. So that's already
Exactly.
very valuable. You're going to be saving time. You're going to have a cleaner code. That's obviously a great use case to use AI as a code assistant. But this example is great for the audience in general who are not savvy in coding, because you manage to demonstrate that provided you do understand the pain you want to solve, it's all a matter of bring the files, you pass everything you have to the LLM, and provided you create a detailed prompt describing exactly the data, this data structure, everything you know about the pain you're trying to solve, the code is generated for you. So it didn't need you to be a code expert to generate a very useful piece of code.
Exactly. This is very valuable in this period of AI development, because previously I had to spend, as I mentioned, a week to create similar complexity tools of similar complexity. I can spend maybe 3 or 4 hours to get a working prototype.
Absolutely. All right, Ivan, thank you very much for coming on. This is very valuable. I'm sure a great number of members
Okay.
of my audience are going to enjoy this. Let me know later if you can point me to whatever resources you can share in your GitHub repo or this slide deck or anything you want to share. I'm going to add it to the published YouTube video with the recording of this session. Okay?
Okay. I will discuss with you in LinkedIn or email.
Yeah, absolutely, mate.
Okay. Sounds like a plan. Thank you. Thank you,
Awesome.
Alan, for having me.
Thank you very much, Ivan. Appreciate it.
Thanks. Thank you.
Good stuff,
Thank
man.
you.
Take care.
Goodbye.
Cheers.